Regulators. Regulators! Mount up.
Well, good morning, good afternoon, or good evening. This is the regulator here. And in this video lesson, I'm going to go over with you how to solve a linear system by elimination. So we're going to be solving a linear system by elimination. Some books, some teachers call it solving by combinations. I like to call it solving by elimination because what we're going to do is eliminate a variable. Okay? Now, when we solve this system, this is two linear equations. So we know when we graph this, what we're actually doing is we're finding the equation of the line, or we're finding the point where these two lines intersect. Okay, so real quick, just to look at it, just to keep it fresh in our minds on what we're doing here, I'm going to graph these two lines. Okay, so I'm going to go in my calculator, I'm going to go graph on the menu. If there's anything in there, I'm going to delete it out. Okay, now I also notice here, I know we're okay on these, right? Sometimes when we graph inequalities, if we've changed the type of graph, we're going to get the inequality, so always make sure it says y equals up there. If it doesn't, then you hit type and then F1 for y equals. So to put this in slope-intercept form, all I have to do is take the 2x over, and y would equal negative 2x minus 22. Okay, and then y sub 2, I'll put this other line, which bring the 3x over, it becomes negative 3x, and then minus 30. Guys, notice how when I had something that was negative, I used the little minus button down here. And when I was subtracting, I put the subtraction button. Okay, so now I'm going to draw those two graphs. All right, I could see them intersecting right here. All right, there's the two lines. If I want to see them better, I could hit zoom auto. Right, well, that didn't turn out much better. When you hit zoom auto, the calculator picks what it thinks are the best y's to go with your x's. So I still had x going from negative 10 to 10. It picked y to be negative 60 to 0. And thinking about it, I'm going to go back to a standard. We didn't really need to change the y. We can see that there. Maybe I'll just go to the window and I'll let x start at negative 20. Right? It's just going to give me a better view of this system. Okay, now I can see the two lines coming down, they intersect right there. So I hit F5 for G-solve, and then F5 again for intersection. Look at the point of intersection. I'll go ahead and take a picture here so this will be fresh in our minds as we're doing this. The point where these two lines intersect is the point where x is negative 8 and y is negative 6. And you definitely want to keep that in the back of your mind. That's what we're looking for every time. Now, when we solve by elimination, that means we're going to want to eliminate one of these variables. Okay, so if I look at these, this has a plain y here and this has a plain y here. So all I have to do is take this bottom equation and I'm going to subtract it from the top equation. So I could write like that, or I could even do this. Because I could just say, okay, I'm going to put a line here, and I'm going to subtract the bottom one from the top one. So 2x minus 3x would be negative x. Y minus y would be 0. See how I eliminated the y's? Then I got my equals. Negative 22 minus a negative 30 would be 8. And I divide both sides by negative 1, and I get negative 8. Okay. Now, you guys, sometimes people don't see clearly that we're subtracting. So what we could do, if I want to go back here, I'll undo what I did there. We could think to ourselves, okay, I've got a positive 1y and a positive 1y. I want one of them to be negative. So I'm going to leave the top equation just like it is. 2x plus y equals negative 22. The bottom equation, I'm going to multiply everything by negative 1. And that will give me a negative 3x minus y equals 30. Now if I add these equations, 2x minus 3x is negative x. The y's are eliminated. That's why we call it elimination. And negative 22 plus 30 is 8. Then we divide both sides by -1, and look at that. We get x equals -8. Now, once we find our negative x, or our x, all we have to do is plug it into one of the two original equations. Maybe I'll plug it in the top one. I'll put -8 in for x. So I get 2 times -8 plus y is going to equal -22. So 2 times -8 is -16, plus y is -22. If I take the -16 over here, it becomes +16. And -22 plus 16 is -6. Guys, look at that. It's deja vu all over again. That's the point when x is -8 and y is -6. Hey, I could always check it. I'll plug -8 into here for x and -6 into here for y. 3 times -8 would be -24. Then a positive and a negative make a -6. -24 minus 6 is -30. That's what I was supposed to get. So boom, we've solved that by elimination. Okay, let's run through a few more examples. Let's solve this by elimination. Well, when I look at this one, I've got a similar situation, right? But this time the y's are negative. Okay, here I got a -2x and a positive x. It might be easier in this situation to eliminate the x's. Right? If I could make this a 2x and then add it to -2x, those would eliminate. So on this one, I'm going to leave this top equation like it is. -2x minus y equals -8. And I'm going to take this bottom equation and multiply everything by 2. As long as I do it to every term, or I do it to both sides of the equation, I don't change the value of the equation. So if I distribute the 2 through here, I'll get 2x minus 2y equals -10. Now if I add these two equations, look at this. The -2x, positive 2x, they're eliminated. They cancel out. -1y minus 2y is -3y. -8 minus 10 is -18. And I divide both sides by -3, and y turns out to be 6. Okay, now, once I get my y, I want to plug it into one of the other equations to find my x. I think I'll plug it in this bottom one here. So I've got x minus y, which I'm going to replace with 6, equals -5. So I bring the 6 over here, it becomes positive. -5 plus 6 is 1. So I'm going to say the point where these two lines intersect is the point when x is 1 and y is 6. Before I box it in, I'm going to check it. I'm going to go back to the equation that I didn't use, this one right here. And I'm going to put 1 in for x. So -2 times 1 would be -2. That's going to be minus y, which I'm saying is 6. -2 minus 6 is -8. Boom. I feel good about that answer, so I box it in. Guys, it's really that easy. I know what you're thinking right now. You're thinking, right? It's that easy. Let's do another one. Let's solve this by elimination. Okay, now this one is a little bit different because there's not, well, for example, in this first one, I had just plain y, so all I had to do is make one negative. Just had to manipulate one equation. This one, I had a -2x, so I just had to make this a positive 2x, so I only had to manipulate one equation. This one, it doesn't look like I can do it. Like -8x, positive 5, I can't just multiply this by a number to add it to that and cancel. Same thing with the y's. So now I'm going to have to pick which variable do I want to eliminate. Okay, you guys, the answer is whichever one's easier to eliminate. Sometimes they're both the same, and then you can do that. So when I look at this, I don't see an advantage over either one. But as I've looked a little bit more, 5x plus 5y equals 20. What if I took that equation and I multiplied or I divided every term by 5? Okay, then I'd get x plus y equals 4. Now, if I leave this top equation the same, I have -8x minus 2y equals -14. Okay, Now this one looks to me like it wouldn't be too difficult to eliminate the y's. All I'd have to do is take this bottom equation and multiply everything by 2 to get a positive 2y, which would cancel the negative 2y. So I'm going to leave the top equation like it is. Negative 8x minus 2y equals negative 14. And I'm going to multiply the bottom equation by 2, and I'll get 2x plus 2y equals 8. Now if I add these together, negative 8x plus 2x is negative 6x. Negative 2y plus 2y is 0y. Those are eliminated. And then negative 14 plus 8 is negative 6. Divide both sides by negative 6, and x turns out to be 1. Okay, now once I find my x, I would go back to one of the original equations. So maybe I'll go to this bottom one right here. Okay, and I'm going to put 1 in for x. So 5 times 1 would be 5, plus 5y should be 20. So I'm going to subtract 5 from both sides, and 5y would be 20 minus 5 would be 15. I'm going to divide both sides by 5. Look at that. Y turns out to be 3. So I'm saying the point where these two lines intersect is the point where x is 1 and y is 3. Before I box it in, I'm going to check it in the other linear equation. I'm going to put 1 in for x. So negative 8 times 1 is negative 8. That's going to be minus. I'm going to put 3 in for y. 2 times 3 is 6. Negative 8 minus 6 is negative 14. Exactly what we're supposed to get. So I feel good. There's my answer. Okay. Now, guys, as illustration, there's more than one way to do these problems, right? Let's say in this problem I didn't reduce that first equation. And let's say I decided to eliminate the x's. Then I'm going to think to myself, what's the least common multiple of 8 and 5? And the answer is 40. So I'm going to multiply this top equation by 5 and this bottom equation by 8. And watch what happens when I do that. 5 times negative 8 is negative 40x. 5 times negative 2y is negative 10y. 5 times negative 14 is negative 70. Here, 8 times 5, x is 40x. 8 times 5y is 40y. 8 times 20 is 160. Now if I add these, negative 40x plus 40x is 0x, so the x's are eliminated. Then 40y minus 10y is 30y. 160 minus 70 is 90. Divide both sides by 30. And look at this. Y turns out to be 3. If I plug 3 into here, I'll get 5x plus 5 times 3, because y is 3. 5 times 3 is 15. That would be 20. Subtract 15 from both sides, and 5x is 5. Divide by 5, and x is 1. So I get the point where x is 1 and y is 3. You guys know what that is, don't you? That's deja vu all over again. Right? It's the same thing we got before, but this time we just did it a different way. Right? Because we could also solve these by graphing. We can solve them by substitution. Okay? It's whichever method works best for you. In most cases, it's probably going to be elimination. Elimination is the most powerful of the three. If you don't like fractions, elimination avoids the fractions for you. Okay. Let's try another one. Let's try this one right here. All right, so let's solve this by elimination. So I have to pick which variable do I want to eliminate. And you guys, I don't see any advantage of one over the other, right? A lot of times we look for if this had a negative 3x and this was a positive 8x, then we eliminate the x's as one's positive, one's negative. But I don't have that on x or y. So I'm going to go ahead here and I'm going to eliminate the x's. Okay, I could eliminate the y's, but I'm going to choose to eliminate the x's. So the least common multiple of 8 and 3 is 24. So what I'm going to do is I'm going to make this a positive 24 by multiplying it by 3. And then I'm going to make this a negative 24 by multiplying it by negative 8. So 3 times 8x is 24x. 3 times 9y is 27y. 3 times 12 is 36. Guys, don't forget to do the 3 to every term, even over here. That's the most common mistake people make, is they forget to multiply the 12 by 3. And then here, negative 8 times 3x is negative 24x. Negative 8 times 7y is negative 56y. The negative 8 times 19, I believe that's 80 and 72. I believe that's negative 152. But because it's better safe than sorry, so maybe over here on the side, I'll multiply 19 times 8. 8 times 9 is 72, carry 7. 8 times 1 is 8, plus 7 is 15, 152. All right, now I'm going to add these two equations, and look at this. The x's are eliminated. 27 minus 56 is negative 29. Why? 36 minus 152 is negative 116. Okay, and again, you guys, when you do this, when I'm subtracting, since 152 is bigger, I'm really taking 152 minus 36, and I'm making the answer negative. So I'd have to borrow from the 5. It becomes 4. 12 minus 6 is 6. 4 minus 3 is 1. Then bring down the 1. That's how I get the 116. Okay, and then I'll divide both sides by negative 29. And y should be 4. Okay, so 29 goes into 116 4 times. Okay, now once you find one of the variables, you plug it back into either equation to find the other variable. So maybe I'll go ahead and plug it. I usually just plug it in the bottom one. So in this bottom one, I have 3 times x, and then plus, I'm going to do 7 times y. So 7 times 4 is 28, and that equals 19. So then I'll subtract 28 from both sides, and 3x is going to be negative 9. 19 minus 28 is negative 9. I'll divide by 3, and x is negative 3. Okay. So I'm saying the point where these two lines intersect is the point where x is negative 3 and y is 4. Before I box it in, I'm going to check it. Okay, I'm going to put negative 3 into here for x. And 8 times negative 3 is negative 24. Then I'm going to put 4 in for y. 9 times 4 is 36. Well, 36 minus 24 is 12. Exactly what we said it should be. So there's my answer. Boom. I know what you're thinking. It's that easy. All right, let's do another one. Let's try this one right here. Let's solve this by elimination. All right, so you guys, here's another one where we're going to get big numbers. But I'm looking at these two equations, and both of them can be reduced. All right, I'm thinking, is there a number that goes into 27, 18, and 24? You bet there is. 3. So I'm going to go ahead and take this equation and divide it by 3. So negative 27 divided by 3 would give me negative 9x. 18 divided by 3 would give me 6y. 24 divided by 3 gives me 8. All right, guys, look at this now. I've got a negative 9x. This is an 18x. If I divided that by 2, I'd get 9x. 2 goes into 12 and it goes into 18. So I'm going to take this second equation and I'm going to divide it by 2. So 18x divided by 2 would give me 9x. Negative 12y divided by 2 would give me negative 6y. And negative 18 divided by 2 gives me negative 9. Ooh, guys, this is turning out to be very interesting. Look at this. The 9's cancel. Negative 9x, or the x's cancel. Negative 9x plus 9x is 0. And so do the y's. 6y minus 6y is 0. So I wind up with 0 over here. And over here I get 8 minus 9, which is negative 1. Hey, can 0 equal negative 1? No, it can't. So you guys, you know what that means? There's no solution. Right? These two equations turn out to be parallel lines. And we know parallel lines never intersect, so there is no point where these two lines intersect. This is an inconsistent system. Hey, if I was to solve both of these equations for y, watch what would happen. The top equation, I would take the negative 27x over. I get 18y equals 27x plus 24. I divide everything by 18. And I wind up with y equals 9 goes into 27 3 times, 18 twice, so 3/2 x. And then 24 over 18, 6 goes into 24 4 times, 18 3 times. The bottom equation, if I solve that for y, I take the 18x over. I get negative 12y would equal negative 18x minus 18. I divide everything by negative 12. And y would equal, here 2 negatives make a positive. 6 goes into 18 3 times, 12 twice. And then plus, or 2 negatives here make a positive. 6 goes into 18 3 times, and 12 twice. So look at this. They have the same slope, but different y-intercepts. So they're parallel. And again, you guys, if we didn't, just to illustrate here, if I didn't do this by dividing by numbers, okay, I could have always solved this by elimination by looking at this and thinking to myself, hey, the y's have a positive 18y and a negative 12y. So I could multiply the top equation by 2 and the bottom by 3. And if I do that, I get negative 54x plus 36y equals 48. The bottom equation, I'd get 54x minus 36y equals negative 36. Right? I just thought to myself, how could I make this positive 36 and this negative 36? That way the y's cancel. Look at this. The x's also canceled, and we end up with 0 equals 12. Well, 0 can't equal 12, so there's no solution. Right? If you ever get 0 equals a number other than 0, there's no solution. All right, let's give one more shot. Let's try this one right here. Let's solve this by elimination. All right, so on this one, I've got a negative x and a positive x, so I think I'm going to eliminate the x's. Least common multiple of 3 and 4 is 12, so I'm going to multiply the top equation by 4 and the bottom equation by 3. That will give me a negative 12x and a positive 12x. So I do that here, I get negative 12x plus 20y equals 8. And here I get 12x plus 9y equals negative 66. If I add these equations, look at this. The x's cancel, they're eliminated. I get 29y, and then 8 minus 66, I believe, is negative 58. Divide by 29, and y is negative 2. If I plug that in this bottom equation, I'm going to get 4x, then 3 times negative 2 is negative 6. It's going to be negative 22. Bring the 6 over here, it becomes positive. 4x equals, excuse me, negative 16. Divide by 4, and x is negative 4. So I'm saying the point where these two lines intersect is the point when x is negative 4 and y is negative 2. I'm going to check that. Negative 3 times negative 4 is 12. 5 times negative 2 is negative 10. 12 minus 10 is 2, just what it's supposed to be. Bam. There's my answer. You guys, it's that easy. And what do we like to say when something's that easy? We like to say "ite." Guys, remember, "ite" is short for it's that easy. It really is. It's that easy unless we make it harder. Okay, let's do one more. Let's solve this by elimination right here. All right, so this one, if we want to solve by elimination, you guys, on just first inspection, these are exactly the same two lines, aren't they? Right? These are the exact same two lines. And watch this. If we want to do this by elimination, Maybe I'll take this top equation. I'll multiply everything by negative 1. So if I do that, I'll get 4x minus 2y is 12. I'll leave the second equation like it is. Negative 4x plus 2y is negative 12. Right. If we add these together, we wind up with 0 equals 0. Everything cancels out. Guys, when 0 equals 0, it means these are the same line. They're two different forms of the same line. They coincide. When they're the same line, there's infinite solutions. Right? When they intersect, it's a consistent system. When they're the same line, it's a dependent. It's a consistent dependent system. So this is a consistent dependent system. Okay, when they intersect at just one point, it's a consistent independent system. When they never intersect, right? When they're parallel lines, right? Like we got here, they never intersect their parallel lines. That's called an inconsistent system. All right, so you guys, we've got a plethora of examples there, right? We even went over when there's no solution, when there's infinite solutions. The key is now you have to work at this. You need to do the homework. You need to ask questions if you don't understand. Remember, ultimately, you're responsible for your grade. And you guys, we all know, if it's important, you'll find a way. If not, you'll find an excuse. So work, try your best, and always endeavor to persevere.